Hello everyone, welcome to my channel. Today's video we'll be discussing this very beautiful question that came in JEE Main Jan. So the students who have a fair knowledge in functions, application of derivatives and area under the curve will be benefited from this video. So without any delay, let's start with the video. First, when you see this kind of question, what should be your approach? The question says, is a real to real function which is twice differentiable, and they given a structure for this function, and it is also said that x and y both are real numbers. Okay, and what else? Few of the constraints that are given, that f dash 0 equals to 4a, and also f double dash x minus 3a f dash x minus fx equals to 0. It is also given that a is greater than 0. Okay, so question asks us to find the area of the region that is bounded by this. So if you see what the question is asking to find this area, the area also consists of one item which is A, which we don't know what is the value of A. So first, where the approach should be, we have to find out the value of A. So to find out value of A, what do we have? We are given these two constraints, correct? This one and this one. Okay. However, to find A from these two constraints also will require some bit of a knowledge about the function fx. So from where we can get that function? We can get function fx from this. So this is the overall approach. So first we'll determine the function fx, then we'll determine A from the constraints, and then we'll find the area which is given in this question. Okay, so f x plus y equals to fx fy. So if we put y equals to 0, this will give us fx equal to fx into f0. This would give us two solutions. If you take the fx in one side, this will give you fx into f0 minus 1. This equals to 0. So this will give you two solutions. One can be fx equals to 0, yes, f0 equals to fx equals to 0 is not a possible solution, right? So this is the first, f0 equals to 1. Now in the next stage what we will do is we'll put the second stage, we'll put y equals to h. So this will give us fx plus h equals to f8 into fx. If we divide both sides by fx, we get now we'll subtract 1 from both the sides. So we'll get f of x plus h minus fx divided by fx. This would be equals to f of h minus 1. So Just by rearranging with a division of h, you will get fx plus h minus fx divided by h equals to, again we have to divide by h in this side also, fh minus 1 by h. So if you remember, my friends, this is pretty much looks like the definition of derivatives that we learned at 11th standard, correct? So if we take limit at both sides, limit h tends to 0, f of x plus h minus fx by h equals to fx, again limit h tends to 0. Here we'll do some twist, f of 0 plus h minus f0 divided by h. Now if you ask me from where did I get that, see, the earlier one we determined that f0 equals to 1. So definitely we can replace this 1 with f0, right? Not now what we will get from here, we can say this means f dash of x is equals to fx, correct, into f dash 0. You see the question says f dash 0 equals to 4a. So that means f dash x equals to fx into 4a. I hope till now it is clear. Suppose we take fx equal to z. That means really dz dx equal to 4a into z. If you integrate both sides, you will get dz by z equals to 4a integration dx, which will give you ln z equals to 4a x plus c, where c is a constant, integration constant, right? Now from here what we will get, z equals to e to the power 4ax plus c, which eventually we can break down to e to the power c into e to the power 4ax. That means k is a constant which is equal to nothing but equals to e to the power c into e to the power 4ax, which is also fx. So fx equals to k e to the power 4ax. And this also satisfied the fact that if 0 equals to 1, which means this, from this function we can say that if 0 equals to k to the power 4a 0, which is nothing but equals to k into 1, that means k equals to 1. So we get the function fx equals to e to the power 4ax. So this is my first part. Now in the second part, what we were supposed to determine is the value of a. So we are given in this question that f double dash x minus 3a f dash x minus fx equals to 0. So f double dash x minus 3a f dash x minus fx equals to 0. This gives us, if we just differentiate this function, we'll get f double dash x equals to 4a, again 4a, e to the power 4a x. The other one would be minus 3a into 4a e to the power 4a x minus e to the power 4a x, and this would be equals to 0. And this brings us e to the power 4a x. If we take common, we'll get 16a square minus 12a square minus 1. This is equals to 0. Now, e to the power 4x cannot be 0, correct? So definitely within the bracket what we have 4a square minus 1 equals to 0. Now this gives us a equals to plus minus half. However, there's one point that question gives us, given a is greater than 0. So remember, here it is given that a is greater than 0. So this brings us to, hence a equals to half. So again we will go back to the function earlier we found is fx equals to the power 4ax. Putting a equals to half will give you fx equals to e to the power 4ax equals to e to the power 2x. So this would be your second part, correct? Now what did we say? The third part is the actual answer that was asked in the question, which is the area. And the area has to be the function y which caters from 0 to ax, and that also with a bound of x from 0 to 2. So we just draw the function, we will get the x-axis, this would be my y-axis, the x-axis from x equal to 0 to x equals to 2. There is a bounded function, and the function is e to the power 2x. It says that 0 less than equals to y less than equals to f of ax. F of ax means f of x by 2, right? Now, if it is so, then f of x by 2 means what? Then y is basically 0 to e to the power x. So e to the power fx is equal to e to the power 2x. So fx by 2 would be e to the power x. So if I bound with that value of y, then the area would be y equal to 0 means this, and y equals to e to the power x means this. This would be my y equal to e to the power x. The question asks me to find the area, find this area. Now, how do I find this area? We simply integrate the function y from x equals to 0 to x equals to 2. So the area under the curve A, this would be equals to integration 0 to 2 y dx. That means integration 0 to 2 e to the power x dx, and integration of e to the power ex means ex. So this means e to the power x with a lower limit 0 and upper limit 2. And that gives you e square minus 1. Hence, option 1 is correct. Thank you everyone. Hope you have enjoyed the video. Please don't forget to like this video and share with your friends. We'll meet in the next video.